We are now starting question number 15 for the topic of work power energy for this M1 paper. A racing cyclist whose mass with the cycle is 75 kg works at a constant rate of 720 watt while moving on a straight horizontal road. The resistance of the cyclist motion is constant and equals to R Newton. Part 1. Given that the cyclist is accelerating at 0.16 meter per second square and at an instant when the speed is 12 meters per second, find the value of R. Part 2. Given that the cyclist's acceleration is positive, show that the speed is less than 15 meters per second. So in this question, they are talking about the walking of that cyclist on a straight horizontal road. So let's make first the figure of this. And here is the cyclist. This is the normal reaction, R1 of that part. This is the weight. This is the driving force. And this is the reactional force, which they have mentioned it as R there. Where mass of the cyclist is 75 kg. Acceleration is given there as 0.16 meter per second square. And it has moved with the speed of 12 meters per second. We know from this equation of motion and the data that the driving force minus the resistive force is equal to the net force MA. But they have given the power there equal to 720 watts. We know from this equation power is basically equal to driving force into velocity. So power is 720, driving force is unknown, and velocity is there 12. So driving force will be equal to 720 over 12, which is equal to 60 Newton. Now we can apply this formula number 1 for this part, that the driving force is 60 minus resistive force is R, as they have mentioned in the question, equal to mass of that particle is 75 and it is moving with an acceleration of 0.16. So 60 minus R is equal to 12. R is equal to 60 minus 12. R is equal to 48 Newton. So this is the first part of that question statement there. In the second part, they are asking about given that the cyclist's acceleration is positive, show that his speed is less than 50 meters per second. Since acceleration is positive, so we know that driving force minus resistive force is greater than 0 because acceleration is positive there. But the driving force is basically equal to power over velocity. So this will become power over velocity minus resistive force is 48 and that should be greater than 0. Power is 720 over V is greater than 48. 720 is greater than 48V or V is less than 720 over 48 or V is less than 15. So that is why they said that it can be less than 15 meters per second if its acceleration is supposed to be positive for this question for the particle moving on the horizontal surface there.